Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now, near the beginning of this series of courses, I said that modules and classes were containers for the methods that you create. But I did say at that time that classes had a special purpose, and I think you'll start to see that special purpose emerge as we continue through this series of courses. Now, the .NET Framework Class Library is a library of code created by Microsoft that we can use in our applications, right? And I explained that the methods that we can use in our application, like WriteLine, ReadLine, and the others, they're all packaged inside of classes. So to get to a specific method, we would use the class name. Then we would use the member access operator, the period operator, and then the name of the method that we wanted to invoke. And I explained that the console class contained methods that were all related to working with the Windows console. And we saw the random class, and the random class has methods as well. We only used one of them, but it has a method called next, which allows us to generate the next random number that the class can generate. So the methods are organized into the classes based on their relationship or their need, or kind of organized that way so that you can easily find what you're looking for. Now, truth be told, I totally oversimplified the explanation about classes because I really wanted you to gain some confidence in yourself and your ability to write Visual Basic code before we introduce classes. It's a little higher conceptual. There's nothing hard about classes per se. It's just that classes introduce the idea of object-oriented programming, and sometimes new developers find object-oriented programming ideas a little bit challenging, at least at first. Now, not to scare you away, but it took me a little time to kind of wrap my brain around object-oriented programming. Took me probably longer than most people, just because I was always looking for something harder, making it more difficult than it really was. The fact of the matter is that in one sense, it's very simple, and then in another sense, you spend the rest of your life trying to master it. Okay, so not to scare you off, but it'll be pretty simple, I think, once we get some basic explanations under our belt. The code that you write in methods are ultimately defining the classes of your application. So every method that you utilize from the .NET Framework Class Library is just a class, and that's why it's part of the class library. That's why they named it the class library. Classes are all around you. You've been using them up to this point pretty much for every little application that we've written. And so you're really an old pro at it. I'm merely going to fill in some of the details to what you already know in this lesson and the next few lessons, and kind of round out your knowledge. And then maybe someday, whenever you sit down to build a real application, a new application, you'll start to see the value of classes, and maybe you'll even start to think like an experienced software developer who might organize their methods into the various classes to help in a number of different ways, to help organize their thinking, to make their code more maintainable, and so on. But at this early point in your software development experience, I just want you to be able to utilize the .NET Framework Class Library efficiently. So I want you to be understand the nature of classes and how to create an instance of a class, create an object, how to utilize properties and methods of a class, and so on. So the truth of the matter is that I couldn't possibly cover everything there is to cover about object-oriented programming, and specifically about classes, in this course. There's just not enough time because it's a vast topic. I have an entire course devoted to it on devview.com, and then you can go on from there and read books and books and books about object-oriented programming. I just wanted to present enough information to you to help you get comfortable with the basics of how to use the existing .NET Framework Class Library from Microsoft. Use those library classes in your applications. And so in order to illustrate how Microsoft put together the .NET Framework Class Library, we're going to build our own custom classes, and to show you how they built the class library. All right, so what I want to do is start talking about the need for classes and talk about working with related properties. So suppose that I want to create an application that keeps track of data, keeps track of data about cars because I own maybe a company that deals with a car lot. I'm selling cars on my car lot, and I want to keep track of all the cars on my car lot. All right, so I want to keep an inventory of all the cars that are currently in my possession as the owner of the car lot. So what I could do probably to begin with here is to create a series of variables about a given car, and I just maybe want to keep track of 3 properties of each car. So I have one car on my car lot. I'm going to say car number 1, and I want to store its make as a string, and I want to store its model as a string, and then I also want to store, whoops, this should be car 1, and then car 1 year as integer. And so then maybe I come along and I need to add a second car. I've got 2 cars on my car lot now. I might need to go car 2 make as string, dim car 2 model as string, and then dim car 2 year as integer. And then what if I get a third car? Well, here we got to do that all over again. Car 3 make as string, dim car 3 model as string, dim car 3 year as integer. All right, and then I decide, well, you know what I really need to do is not only keep track of the make, model, and year, but I need to also keep track of the color for each of the cars. So, I gotta do car 1 color as string. All right, and then gotta go down here, add car 2. You can see that this isn't a very efficient way to keep up with all the cars on my car lot. Okay. First of all, I'm kind of relying on just a naming convention, just like I did with arrays. Remember when we talked about that? Relying on a naming convention to keep everything kind of bundled together, and there's no way to enforce that. There's no way to enforce that. What I'm saving in car 3 color isn't related to car 1. Why? Because these are just loosely related together, and the only way that they're related is in my own mind, and the only reason they're related in my mind is because of what I've named them. So this isn't a very good technique for keeping related attributes of a single entity, a single object, a car in this case, into one logical container. When I think about it, arrays really aren't the right way to go about this either, because you can only store a single data type inside of an array. And furthermore, how would I keep track of, if we were to say car 1 and, say it had 4 attributes, how would I be able to say that attribute number 2 was always the model, regardless of car 1, car 2, car 3? So that arrays aren't really the right solution for this either. What we would probably want to do instead is actually to create a new class of information, a classification, a type. And that type would be a car or an automobile. And a car would have different properties. And then whenever we went to represent a new car on our car lot, we could just say car 1 is actually type of car. And since it's a type of car, we know that it has a make, model, year, color, and so on. So here's what we want to do. We want to create a new class, and inside that class we're going to define the properties, the attributes of a car that are meaningful in our application. Now there's a lot of attributes about a car. We could say sticker price, we could say the number of miles that it has on it, but those things may not be relevant to the application we're building. So we really just want to model those properties that are interesting to us inside of our application. So what I want to do is add a new file to my project. We haven't done this yet. And there's a couple of different ways to go about this. The easiest way, in my opinion, is just to go to the project menu and select add. And one of the options is to add a class, and it will pop open a new dialog called the add new item dialog. It'll already pre-select class. We can add a lot of different types of things, but class is what we want. Let's name it car.vb and click the add button. Okay, so now we have, you can see here, a public class car. I'm not going to talk about the word public just yet. That'll come in handy here when we talk about accessibility modifiers a little bit later. But for right now, all I'm really interested in doing is defining what a car is inside of my application. And again, car lot, I just want to keep track of the make, the model, the year, and the color. So what I'm going to do is create 4 properties of a car that are general and they're applicable to every car that's ever been created on the face of the earth. Okay, so it's a generalization of the idea of a car. So in this case, public, and we'll give it the name property, make as a string, public property, model as string, public property year as integer. Here, let me fix that E in year. And then finally, public property color as integer, whoops, as a string. Great. Let me change the R. I know that it's not case sensitive, but I like making my code read correctly. Great. So now I've got a car class, and it allows me then to create new instances of cars. Each car will be defined or differentiated as a make, a model, a year, and color. Now I can create a new bucket in the computer's memory sufficiently large enough to hold a new car object. It's just like an integer. It's just like a string. It's just like a date. It's just like the console class. It's just like the random class. It's just like every other class or data type that we've worked with, except we created this. It's a custom data type. It's a custom class, and we get to define how that class actually works by creating its properties and its methods. Okay. So now let's suppose that my aim is to use that car definition, that car class definition, to create instances of the car class that represent individual cars on my car lot. So I want to create a bucket in the computer's memory, an instance of the car class that will hold each of the cars. So I might have 2 or 3 different cars on my car lot. I want a variable of type car that will hold all the information about one specific car on my car lot. All right. So let's go ahead and talk then about creating a new instance of a class versus the class definition itself. The class is the blueprint. All right. But what we want is an instance, or we want that blueprint to turn into an actual representation of a specific car. So what we need to do is take this car class and say, I need a new bucket based on this car class definition, and then I'll fill in the details about it. So I need to take the pattern, take the blueprint, and then instantiate it, create an instance of it, realize that from the theory of what a car is to an actual instance of a real car, like my car sitting in my driveway right now. Okay. So, in the real world, you can use the same blueprint to create many different houses, right? The blueprint's just on a sheet of paper, but the house actually is at a physical address. And, in some neighborhoods, they call them cookie cutter houses because they all look the same, right? Well, you could use the same pattern to create the same shirt or pair of jeans over and over again, or the same recipe to create the same cake or the same casserole and get the same results each time. That's the purpose of the pattern. That's the purpose of the blueprint. So each time you want to build a new house, it'll be at a different address, all right, a different street address. Each time you follow the pattern, you'll create a different shirt. You might use different fabric. It might be a slightly different size, but the pattern will give you the overall shape of that given shirt. Or every time that you create a new shirt, you can sell it to a different customer. There's an instance of it that you create from the pattern. Each time you follow a recipe, you're going to create a different meal available and that can be eaten by a different person, okay? So the same is true with classes. Each time you create a new instance of a class, you have a new object that's distinct and separate from the other instances of that class, all right? It lives on its own, in other words, is what I'm trying to say. So think of the class as a cookie cutter. You can't eat the cookie cutter, right? You can eat the cookies that you make from the cookie cutter. So when you instantiate a class, you create a cookie, or an instance based on the shape of the cookie cutter or the class, okay? So I'm going into a lot of conceptual explanations of the difference between a class and using the class, or the cookie cutter and using the cookie cutter, or the pattern and using the pattern, the difference between the blueprint and actually using the blueprint to create a new house or whatever, okay? So hopefully I'm making that distinction extremely clear. Once you can get that clear in your mind, things will come so much easier, all right? And so what we want to do is create a new instance of a car. Let's go ahead over to our module VB in our submain and create a new car. So dim my car as car, all right? Now at this point, all I've done is created a label that I can attach and say this is of type car. Now, in order to actually create the bucket in the computer's memory, I have to use a different keyword. My car equals new car. At this point, the new keyword's like a factory. It takes the blueprint and it creates an instance of the object, in this case a car, and it essentially creates that bucket in the computer's memory. And at that point then, we've created the item in memory and we've got the name or the label for that bucket, my car. And so now we're ready to work with my car. And we can do something like this, my car dot make equals Toyota. My car dot model equals 4Runner. My car dot year equals, I think it's 2010, and then my car dot color equals white. Okay, so now that I have a bucket in the computer's memory labeled my car, I can set the properties or the attributes of my car and describe my car using the various properties that have been predefined for a variable of type car. So here we've got a class, but the class is called car. An instance of my car or of the car is called an object. So here's the class and here's the object. Here we create a new instance of the car class in the computer's memory. We instantiate it, we bring it to life based on the fact that we know its definition, the cookie cutter here, the blueprint. And now that it's in memory and we have a connection to it by its label, my car, we can start working with it. All right, and we can create a second car. Dim my other car as car. In fact, we can do this all kind of in one shot equals new car, like so. So we've done these two lines of code, except in one line of code. Actually, there's an easier way to do it with still less code. My other car as new car. All right. Actually, let me do that. Okay. So that's probably the shortened form that you'll find me using most often because I can do it all in the fewest number of characters possible. And so then my other car can be a make equals, let's go Honda. My other car is the model. Let's call it a Accord. My other car dot year is 2012. My other car dot color equals black. Okay. Now that I have two cars, I can console.writeLine, and I can print out the specific attributes of each car. So let's just do two things here. And let's take my car dot make and then my car dot year and print them out. Like so. And I can do the same thing here with my other car. I just copied and pasted that line, and I'm going to change what we're printing out. And here you can see I have a Toyota 2010, Honda 2012. All right, and I think the most important thing to realize about this is that I can set properties using the assignment operator, but I also can get the properties just like I can any other variable by merely referencing it using the name of the object. In this case, my car, it's the instantiated version of the class, so it's an object. So that's the difference, a class versus an object. Class is the blueprint, the object is the instantiated version of it that has, it's different from every other instance because it's a different bucket in the computer's memory, okay? So hopefully I've belabored that enough so that you understand it. So you can see that we create many instances of a single class by giving each instance of the class a different identifier, a different name, all right? And so it's distinct from every other item based on the same class in the computer's memory. Now, I've merely hard-coded the values here in this example. Typically what you would do is retrieve those values, maybe from an end user, letting them type in the values. We might pull it from a database or from a file and instantiate an object and then copy the attributes from the file into the object and then work with it and then save it back. So again, here we're taking baby steps, but that's how we would get information in. We probably wouldn't always just hard code them the way that we've done here. It would make for a very inflexible application. What we really want to do is either retrieve data from an end user or retrieve data from some file source or from some online source. Okay. Now I want you to notice also that IntelliSense was smart enough to show me all of the attributes that we've created, right? As well as a few extras like equals, get hash code, and get type. That's because every object or every class is actually based on a kind of a grandfather. It inherits from system.object in the .NET Framework class library. So even though we're creating a custom class, it's really borrowing from the definition of what a class really is that's defined in the .NET Framework class library. So we get some functionality for free, like the toString method, the get type, the get hash. That's where all these other things come from, but they don't really have any functionality just yet by default. We could override their default implementations and do something interesting with them, but we won't do that in this video. Okay, so I just wanted to point that out. Now, the next question is, how long does this instance of the car or the other car stay around? Well, as long as we're using my car or my other car in our application, then it will continue to stay alive. But when we stop using it, it will die. And we'll talk about the scope of variables, but specifically about objects, as well as object lifetime in an upcoming lesson, because it's a very important concept. But essentially, when we get to the end of our sub, what will happen is those two cars will be removed from the computer's memory, thrown in the trash, and that memory is now freed up for other applications that we have on our computer. Okay. So also what I wanted to point out here is that we used a shortened version of defining a property. There's actually a longer version that allows us to add more functionality inside of our properties. So this version is called an auto-implemented property. We're able to create a long version of the property just by typing in the word property or prop, have it highlighted in the IntelliSense and then hitting tab. And here you can see a fully implemented property. And I don't want to really get into all of it, but you can see that it does have these two little sections here, the get and the set. So that's the two operations that you can perform on a property. You can get or retrieve its current value, or you can set its current value by passing it a new value using the equal sign, the assignment operator. This full-blown version of a property allows me to step in and write custom code, custom logic, so that when anybody tries to access and retrieve the value of an attribute or change the value of an attribute, we can stop it and say, wait a second, before we give away the value that's inside of our new property, let's make sure that they have the appropriate level of access, because I may not want to give away some super secret information if the person who's currently logged into my application is not of a certain level inside of our organization. So this is where we could do some gating and stop people from accessing information at this property level. We could also then do some validation and say, a car can't be, 2030. That year hasn't even come yet. So we could validate the set and only allow certain values to be set. So if we tried to set, for example, the year to 2030, we could throw an error and say, no, you can't do that. So that's the purpose of a full-blown property definition, but we're not going to use that, not at least in this video. I just wanted you to be aware of the fact that this is a shorthand version of creating a property. This version of the property allows us to get it or set it, and set it to any value that you could typically set into a string, even if it doesn't make logical sense inside of our application. Okay. Now, since we defined a data type, just like string or integer, we can use those as input parameters to functions. So what if I were to create a little helper method here and to determine the value of each of our cars? What we could do is create a new function. So I'm going to call this determine market value, and then I'm going to pass it in by val my car as car, and I'm going to return back a money value. And whenever you're dealing with monies, you want to deal with decimals, the decimal data type. Okay. So when you're dealing with money, you want to work with the decimal data type. It's like integer, except it allows you to have values after the decimal place. And so in this case, what I could do is do some super secret formula here to figure out what the value of any given car is. I could even go and search online to find the value of the car, but we're not going to do that. Instead, I'm just going to hard code and return, I'm going to return the value of 100 for the car. So we're going to pass in my car. We're going to do some evaluation on it. We could like retrieve its properties here, mycar.make. So maybe we'll do that in a future example. But we could evaluate it, pass it to something online, get the value, and then return it back. So here, if I were to, let's comment this out. And let's just do this. My car, let's go determine market value, and we'll pass in my car. All right. Then we'll see what the current value of my car is. All right. You can see that it's 100. Let's go ahead and format it like currency, right? So I use the :C formatter. Now we can see the value of my car is actually $100. All right. So the point here is that we can use now this data type car that we define just like any other data type, integer, string, date, whatever, and we can use it as input or as return values from functions that we create. But there's maybe an even better way to do this. Let's talk about creating methods inside of our class definition. So I said before that a class is really just a container for your methods, but I haven't shown you any methods. I only been talking about the properties, but we can also create methods inside of our classes. So let's do that. Instead of putting that determine market value here as a function that we pass the car into, we should be able to just create it here inside the class. It will have access to all the data that it needs in order to make the determination. So we shouldn't have to pass in anything. We'll just say, let's go just public function market value as decimal. Okay, so we're not passing any values because we're going to be able to access the attributes of this car. So let's go ahead and we could do something like, the super secret formula right here. We could actually look online for the value and then return it. But what I'm going to do is something a little bit different. We'll just write some really crazy logic here to determine the car's value. So I'm going to create a car value as decimal. This is ultimately what I'm trying to determine. I'm just going to create a variable that'll hold it. And now what I want to do is find out the current year of the car. Now I could just type year like that and it would work. But what I would really prefer to do is to say not just year, because year, where did this come from? Is this just some, it might be difficult to remember the properties of a car. If I were to look at this in the future and say, I don't know, I'm looking at this function, it's not clear to me where this year word came from. So what I can say is for this instance of car, this current instance, give me the year attribute. Now I prefer doing that. Clearly, Visual Studio would say, well, you could probably simplify this, and it gives me the little light bulb under it, and it said just remove the me qualification. All right, so we'll just go ahead and leave it off. But remember, if you want to reference this specific instance of the class and retrieve its attributes, its year, its make, its model, then you can use the me dot. All right, but we'll get rid of it. So at any rate, if the year is greater than 1990, then the car value, we'll just hard code it to $10,000. Otherwise, if it's older than 1990, then we'll make the car value just $2,000, and then we'll return the car's value, like so. Okay. And now let's go ahead and rework this line of code. And we'll just go console.writeLine. In fact, let me just borrow almost everything inside of here, except we'll change how we make a call. And in this case, we're just going to go mycar.determine mycar.marketValue. Okay, I thought it was called something else. And so now I'm going to be executing a method, so I have to use the method invocation operator on it. It's not a property. Properties, I don't have to use the method invocation operator. Even if I try to, I'll probably get an error. All right, it lets me do it, but again, that's only because Visual Basic is very forgiving, and I can probably leave it off here too, and it will still work. But again, I want you to be purposeful and think about the usage of a property versus a function, or rather a method. Let's run the application, and you can see now that our Toyota is worth $10,000. All right, so what do you make of all of this? Well, in this lesson, we used a very concrete example, the example of a car. And a car is easy for all of us to conceptualize. It's tangible. There's a real-world equivalent. We can think of what a car really represents in the real world. We can model it fairly easily because we know the attributes of a car, just like we know the attributes of, a pad of paper or whatever the case might be. Now, you're going to be building applications, especially in this series of lessons, and typically you're not going to be responsible for creating your own custom classes. I think your main exposure to classes will be what we've experienced so far, which is those classes, again, which were created by Microsoft and available in the .NET Framework class library. In most of those cases, the classes that have been defined in the .NET Framework class library do not have real-world equivalents, like something tangible, like a pad of paper or like a car that we can sit inside of or touch. In other words, the classes inside of the .NET Framework class library are more conceptual in nature. For example, I might work with a class that represents a connection to the internet. Or I might work with a class that represents a stream of data as it's being streamed into me from some other source, flowing from one place to the other like a pipeline. And we already saw that there were objects like a span of time. It's difficult to put your hands on time, right? But there are objects in the .NET Framework class library that represent a span of time between two dates, okay? So very conceptual in nature. In these cases, we're not working with something tangible that we can touch and we can feel, but we're working with something, again, a construct of our own minds or something that is that we can't touch inside of the computer. Now, as you mature as a software developer, you might want to invest more time in learning how to create your own library of classes that interact with each other in some meaningful way as a means of breaking down real-world problems into conceptual problems and turning them into code by abstracting their features, their most identifiable features that are important for your application, into a series of classes, okay? And that process that you go through to turn something in the real world into something conceptual is called object-oriented analysis and design. And that's not something that we're going to cover in this series of lessons. You can spend years learning how to do it properly, but I do have some courses on devview.com that will help you learn that if that's something you're interested in. I spent a lot of time actually thinking and talking about object-oriented programming there. So, all right, to recap, a class is a data type, just like any of the data types that we've learned about up to now. It's similar to those basic data types like integer and string, and it's also similar to those complex data types like console and random that we've used up to this point in time. And you can define a custom class with properties, as we saw here, and methods, like we saw here, and we can actually then utilize them by creating new instances of a given class and then using the member access operator to either set or get the properties or to call the methods that have been defined on our classes. And inside of those methods, we can access the various attributes of this instance of this given class and then make and create business logic around it to, in this case, for example, determine the value of the car. All right, so don't worry. I've got a lot more to say about classes. If you don't understand everything there is to know about classes just yet, why you need them, that's okay. Don't fret about it. Just make sure that you understand the process that we went through to create a new class, how we created properties of the class by using this syntax, public property, then the name of the property, and then as whatever data type that we want to make that property. Understand the purpose of when we typed in prop tab and we were able to create the full version of a property, and we see here the get versus the set for that property. How we created a method. We could have used a sub. We used a function because we wanted to return a value, but again, how we created a method inside of a class, and then we were able to access that either property or method by using, again, the member access operator for a given instance of our class. And if you understand just that much, then you're doing all the right things up to this point. We'll fill in more details in the coming lessons. So if this didn't make sense, there's nothing wrong with watching this video a second or third time, or even watching other videos that might help you better understand classes. But do this, stick with this. Don't drop it right here, even though we're at a conceptual hurdle for you. A lot of people have a challenge with this, and don't make it harder than it really is, at least not at this point. Okay, so you're doing great. Let's continue on to the next lesson. We'll see you there. Thanks.